Hi, everyone, and welcome to today's webinar about Watsonx.data, built to scale AI workloads for all your data anywhere. My name is Ashley Bassman, the product marketing lead for Watsonx.data, and today I'm excited to introduce our product manager and senior expert from McKinsey to dive into Watsonx.data. Just a couple of weeks ago, we made a major announcement in AI at IBM. We announced Watsonx, a platform built to scale AI across your entire business. Today, to dive deeper into the capability of Watsonx.data and how it can help you scale AI across your entire organization and built on a data lakehouse architecture, I'm pleased to introduce Kevin Shen, our product manager at IBM for Watsonx.data, and Matthew DeMolin, our senior expert at McKinsey & Company. Matthew, I'll hand it over to you.
Thanks, Ashley. The work that I do with a lot of large Fortune 500 organizations as part of McKinsey's Quantum Black AI and ML COE is helping large organizations rework and modernize their data foundations to be able to create complex new value generating ML-based use cases and bring them to production successfully. Not only that, but also to scale this out from a few use cases to dozens or even hundreds of use cases. Doing so is because there is a real ongoing demand and pressure explosion for the business to compete effectively, leveraging data and the latest and greatest of what is possible with business intelligence, as well as artificial intelligence today. But doing so requires having a certain set of foundational capabilities from a data architecture perspective to be able to meet that demand properly. And some of those elements that we would like to highlight are, number one, that the ability to scale AI in compliance with lineage and reproducibility of data. This is especially relevant in a world where large language models come in and bring out all kinds of questions around who can use what, when, and with what data. Being able to follow AI ethics is not just good for your customers, but also good from a risk perspective for your enterprise. Two, real-time analytics and BI. It's not good enough today to be able to meet the needs of the business from an analytics perspective, serving only weekly or monthly reports. More and more speed is demanded by the business to understand what is the inventory situation in my data center, in my distribution center right now. These are the questions that executives need to be answered, and your data foundations need to be able to meet that kind of request from the business. Finally, three, another very important requirement is around data sharing and self-service, because the business cannot just wait for analytics to come from a small team sitting somewhere within the organization. That becomes a huge bottleneck. We want to bring the power of data and analytics throughout the business, but you need to be able to do so with governance and security. Now, we've been trying to meet those needs for quite a while now, and the trend has been for different tools to bring different kinds of solutions, but each coming with certain weaknesses that prompt the next generation to come about, going from data warehouse to data lake and the Hadoop platforms, to cloud native data warehouses, to now the new kid on the block, the first generation of data lakehouses that seek to combine the best advantages from those previous attempts to be able to cover a very wide array of use cases comprehensively and with great performance. However, this first generation of data lakehouses still are far from perfect. For example, they aren't deployable everywhere. Many of them are limited to only being deployable on the cloud. In addition, they don't always address governance in a way that lets us meet those goals of ethical and compliant AI, or data manageability and um, managing user data access permissions in a very comprehensive manner efficiently. And thirdly, you are also locked into a single compute engine that is embedded within this tool. Here, that creates a lost opportunity to optimize the performance as well as the cost at the level of workloads that is currently not possible. Enter the Watsonx.ai platform that seeks to bring certain answers to many of these challenges.
Thank you, Matthew. And to put things into perspective for Watsonx, this is the platform that's going to help organizations put AI to work. And it really focuses on three crucial aspects. The first is the tool sets that will help organizations build their models, leveraging foundational general models to build their workload on top. So that way they don't really have to start from scratch. But with all AI trainings and machine learning, data is at the core of it. Organization needs to manage that data efficiently and being cost conscious while making sure that their data management ecosystem is able to handle all of the data that they're working on today and for tomorrow. Finally, with all the rise of AI and the different tools, trust is really important. It is important for organizations to be able to explain how their algorithms work, whether it's fair or biased, and if it's reproducible. And that's where Watsonx.data governance comes in, to help those organizations making sure that the AI products they put out can be trusted. For today, we're going to focus on Watsonx.data, the foundation for powering all of these capabilities in Watsonx. Watsonx.data not only supports Watsonx.ai and governance, but also brings a lot of values at the foundational data management side as well. It will allow all the organizations to access all their data, getting better return. And we're going to discuss exactly what that means in a second. We're also going to help organizations get started faster with built-in automations, governance, and security, as well as quick starts for anyone who is new to this paradigm of working with data. Then finally, for all of our existing customers and those customers who are not quite there at AI but are looking to, but are struggling with costs on their warehousing and BI today, we have a solution for them as well to help them optimize what they have today while setting up an architecture that is going to help them scale AI efficiently in the future. So first, let's look at how we're going to help customers get better return on their data with Watsonx.data by allowing access to everything. Number one of the biggest time sucks for data management is the requirement to move data from one place to another. Oftentimes, where data is landed from operational sources and where they're ultimately used for final business processings are done in different environments. And often that requires data to be moved and duplicated from one environment to another, which can take a lot of different amount of time. What we have done here is create a lakehouse that have multiple engines accessing the same data storage, integrated so that they can all read from the same metastore so it understands exactly where that data lives and how to read it, and also standardizing around the same table format, which is going to be Iceberg. Through these 3 points of integration, customers can take one tool to perform one set of operations, may that be transformation or calculations, and then immediately have another tool to pick that up and feed it into a dashboard, all without data movement and duplication, accelerating time to value and unlocking the potentials of data sources that they may not be able to easily access from before. On the flip side, organizations have data in many different places, and oftentimes it's difficult to look into those sources and analyze across without having to move the data first. Watsonx.data also supports that by allowing a single Presto engine, the HANA Presto engine, to access data in multiple environments. Through a set of connectors that we support, Users can easily combine data across from cloud, on-premises, relationals, or lake storages with that single engine. Finally, for customers who have data on mainframe, we're enhancing our capabilities there as well by allowing customers to easily get their data from the mainframes into a analytical environment outside. And with the enhancements with DataGate, live twinning will be done for any Z data so that it can be replicated into a DB2 warehouse, which then participates in the Lakehouse ecosystem, unlocking that data for analytics. So now we understand how you can access out your data, but what about getting started in automations? For customers who are looking to migrate their data lakes, oftentimes it's very difficult to move all their data and metadata in one go, and it is an enormous effort to do so. With the Watsonx.data architecture being modular and extensible, customers can simply bring their HDFS data and their metadata to the lakehouse and point our engines at that stack so that they can get value from day one without having to incur any expensive data migrations before they see results. By simply doing this, they can access any legacy data that they have and new data that land inside Watsonx.data and helping them to build new applications right from the get-go. Second, governing data is hard, and it's extremely difficult as well if this is in the context of a data lake. There are no barrier to entry, and there are no structures defined when data lands in. Furthermore, if an organization has multiple data sources, making sure that policies are enforced in a consistent manner is also difficult. Watsonx.data has its built-in governance and security, but it also participates in a global governance story defined by WKC. The analogy I like to make here is that WKC acts as the law, where the policies are written once and enforced in many different places. And each Watsonx.data can act as an enforcement point, or the police officers that are enforcing the policies set up by WKC, so that those abstract policies can be made into discrete enforcement sets that are then executed at runtime, making sure that data is always secure, even if it's only set up at a global layer defined by the central organization. Finally, finding data and working with data and preparing data for BI and AI is challenging. It oftentimes requires extensive documentation on the data set, business glossaries, data catalogs, and the continuous update and maintenance of those table comments and tribal knowledge. We're launching something called semantic automation, which massively simplifies this process by automatically enriching the data sets purely based on the technical metadata, and also through a chat interface and conversational models, allowing users to quickly find the data that they're looking for, making sure that they understand what it means, and also helping them to find relevant data sets that they can combine with to answer their questions. Again, accelerating their time to value and the ability for them to get started quickly. Finally, for our customers who are struggling with cost, we have a solution for you as well. Here, we're looking at ways to better optimize your workloads for the future. Oftentimes, a lot of workloads in existing warehouses are there because it was easy. It wasn't that it was the most cost-effective place to do so, because it was simply easier to do those transformations and manipulations in place rather than to move it, do those somewhere else and then move the resulting set over. Here, we have a way to optimize through a couple of different levers. Number one, we have multiple engines that are integrated, as I shared earlier. By allowing multiple engines to access the same data, metadata, and being able to work in the same table formats, workload can be offloaded from an expensive engine, such as warehousing, to something that's cheaper, like a distributed SQL engine such as Presto. So customers may even actually bring data in with Spark, do the transformation with Presto, and then pick it up with something like Netezza, all without having to duplicate their data or move their data, making this optimization process much simpler than today. Second, for all the customers who are adopting our SaaS managed service, there's an additional way for you to optimize your infrastructures for your workload. Out of the gate at GA, we'll be offering two flavors of infrastructure profiles. One optimized for compute, which is compute dense, excellent for calculating fields, or tasks such as Parquet encryption, where compute usage is very heavy. On the other hand, if customers want to plug in dashboards or are querying over large amounts of data, they can leverage the cache optimized node size, which comes with terabytes of raw NVMEs that can help to accelerate queries for a dashboard so that it remains snappy, or to cache data for a wide table scan to make sure that those queries are accelerated. Finally, out of the box, the Presto engine will be dynamically scalable both on its the size, both on the type of the nodes as well as the number of those nodes. So if you have additional users that are submitting query concurrently or an extra large workload, you have the ability to scale on demand. Finally, putting all of this together and making sure that we're addressing the issues that we're seeing in the market today, Watsonx.data is really positioned as the hybrid lakehouse solution for our customers by allowing them to deploy this solution wherever their data lives so that it has the best performance by being close to the data, and with its integrations able to tackle a number of optimization and modernization use cases well by eliminating duplications and data movements through our integration. Really able to help warehouse customers optimize and legacy data lake customers modernize. So now we're going to take a second to describe what actually makes up of Watsonx.data at a technical level. And we're going to see this live in a demo shortly. So at the foundational layer, there's the infrastructure and storage. And we're really focused on making sure that this is hybrid. So at an infrastructure level, this is available as a managed SaaS service, both on the IBM Cloud infrastructure and the AWS infrastructure, as well as being available on-prem, all built on Red Hat OpenShift, so that customers can deploy this wherever it needs to be. Object storage standard is what we're using for data storage and is widely adopted, and continue to offer this both on SaaS as well as on-prem by including our own prepared Ceph object storages for customers who purchase Watsonx.data. And then finally, to the core of the actual Watsonx.data, there are the data formats that it is all centralized around, which is the Iceberg table format on top of open source data formats such as Parquet, ORC, and Avro. There's also a metadata layer that stores all the informations about the tables and acts as a pointer for Iceberg so that all of the engines reading this metadata can understand exactly where the data is located and how to read it and so forth. Access control is also built into this layer and is loosely based off of Ranger, providing both resource level access control as well as data level access control. Finally, on top, the core Watsonx.data engines are the Presto engine and Spark engine. And these two engines serve slightly different purposes, with Spark being a multi-purpose tool that is good for ingest and transformation, as well as certain data encoding and ML training abilities, whereas the Presto engine is really optimized for large-scale queries, distributed queries at scale that is highly elastic and scalable, and is able to handle many of the modern data formats that legacy warehousing and BI tools struggle with. In addition to these two engines, we also have our warehousing engines, which received a number of enhancements to be able to also work with the object storage standard, Iceberg table formats, and being able to read the metadata located here. And those two warehouses are the DB2 warehouse and the Teza, and we will see that in action today. To start off, I'm going to show the infrastructure manager. And this should look familiar from the diagram that we just saw that makes up of the core components of Watsonx.data. From the bottom, you have an S3 bucket that's attached to this environment. And this is where all of the data is persisted. And if I hover over this bucket, you'll see all of the different catalogs and engines that are attached. So all of the engines above are able to read the same catalog and the same bucket. Likewise, I mentioned that you can also use a single engine to look into other data sources, and this is done through with the Presto engine and connectors. So if I hover over the Presto engine, you'll see that this single engine is able to connect to multiple catalogs and multiple data sources and work to combine data from those data sources. And then finally, in the middle layer, we have the catalogs. These are all the different catalogs where tables are informations are kept so that users can browse them to understand what they want to look for, as well as engines to be able to read off of them and query the data itself. At the top layer, we have engines. The core engines are the ones that are able to be deployed from the Lakehouse itself. And at GA, this will be the HANA Presto engine. And then shortly after GA, this will be the Spark engine. Additionally, I mentioned that we made enhancements to DB2 Warehouse and Atiza, and these are engines that can be associated to this environment so that they can also be integrated with the catalogs and the buckets. But because of the nature that they are separate services, associating them in makes the most sense for any customers who are already running these services. And as an intent, all of Watsonx data is meant to be modular and extensible, so you can add these components as you see fit. If you need a new engine to run additional workloads or to scale out, simply through the add components and create an additional engine. And it is very simple with a few basic informations and selections, and you're able to do so. The same thing with at the storage layer. If you have buckets with data inside or relational data sources, in the add component, you can add these buckets by providing the credentials, and the same thing with add databases, and therefore there. In the future, we'll be able to add additional external metadata stores that may already be cataloged full of customers' data. And you would do so in the add metastore section, where you simply provide the type of metastore you're trying to add and the connection information from there. So now that we have a good understanding of what makes up the core component of the Lakehouse, and also seeing all of these pieces being displayed, let's run through a scenario where we're looking to use a Spark to bring certain data sets into the environment, querying it with Presto, and then looking at an environment situation where we're sharing data between Presto and the end warehouse. So kind of think about it as using Presto as a tool for data ingest and AI training, Presto for data preparation, and then Netiza for the final sets. And from there, we're going to take a look at semantic automations to see how this can be done in the future world. So jumping over to my Spark notebook, and I'm going to just run through the notebook for time's sake, but typically I can also run it, and it will just be a repeat of what I just did prior. There's a couple of setup steps that I'm going to hide because they have connection informations, but it's pretty simple to to figure out the exact metastore storage that this Spark instance can connect to. Test querying to make sure that the connection is real. And then from there, all the user had to do is really identify a Parquet file where the data is stored in its raw format. And this can be an output from the IoTs, different toolings, operational sources, etc. But from there, a data frame is defined, the data is loaded, and then the raw table is written to the underlying Lakehouse storage, as well as writing to the catalog so that it's aware that this is a new table. And as you see here, when I wrote the table to the catalog, this is being written to the think raw data schema under the name user address light. And this is all done by Spark. So if I actually navigate back to the Lakehouse and to the SQL editor, and to find the correct catalog as shown here, we can actually see the same raw data schema and the tables that we just written, US address light. And if we actually select this table and query it, you can see that Presto is able to query the table that Spark just written to it, showing these two working in concert. But that's not it. This table might be good for a business analyst to look at, but if it's going to be fed into a classifiers, let's say if we want to train a model based on zip codes, we may want zip code to be encoded in a way that is binary so the classifier can really pick up truth or false. In this case, we're going to run a dummy encoding process to turn these zip codes into individual columns with binaries. And to do so, we simply have to call a flat map functions again load the data into the necessary data frames and writing this data to a table. And the resulting table that should look like this will be much more useful for AIs to understand and to take action on. And over here in the lakehouse, we can also see the resulting transformations in a different schema. Here, I created a different schema under the same Iceberg beta catalog called AI data. So this is a little bit different from the raw data as we already did some transformations. And if we actually look into this particular table, we'll note that the table is in fact encoded and ready to go. And just like that, we can see that we have the existing table plus all of the encoding fields that makes this ultra wide and ready to use. So now we have brought data in with Spark and we have used Presto to query this data. What happens if I want to share data between Watsonx.data, the lakehouse, and a warehouse instance? So as we've seen in our infrastructures mapping, we have a warehouse associated, namely Netezza, and here is the exact environment for that Netezza instance. If we go back to the lakehouse and look at one of the catalogs that is synchronized with Netezza, we're going to see a couple tables. And here we're going to work backwards, showing what has been done and how to recreate it as such. If we locate the ThinkDB schema this time, we'll note that there are actually two tables located here, a table called order methods and a table called products. And both of these tables are actually tables that I created from a connected DB2 warehouse instance, showing that you can take connected data sources and creating the tables on top. And at the same time, if we go to Netezza, we're also able to see the same two tables. Now you ask me, how do I know this is actually the same data and the same metadata? So we're going to do some manipulations here. The first thing we're going to do is dropping this table to show that, in fact, if we actually do drop this table, the table is going to disappear in the other environment as well. Sorry, pardon me. And just like that, we drop the table and we're going to refresh the catalog. Now the table has disappeared in the lakehouse ThinkDB catalog. What happens if we go over to Netezza? Over here, we understand that the catalogs are synchronized at the metastore level. So we're going to simply run a quick alter database metastore sync. That way, Netezza can grab the latest metadata information from Watsonx.data. And we can run that quickly. And all we have to do is refresh the query editor and the catalog over here, and it should reflect the latest. So if we look at ThinkDB one more time, that order method table is now gone. So one operation that I perform over in the lakehouse is now reflected in Netezza as well. No ETL or data duplication. So what if we want to bring that table back? What if I want to create a set of new tables from existing connected data sources or otherwise? With a simple create table statement, it can take data located in DB2 warehouse and simply create an iceberg table directly inside Watsonx.data. And here is the statement for taking that data from the Go Sales tables and create it in the Iceberg Beta ThinkDB catalog and naming it order method, the table that we just dropped. And all we have to do is to make sure that the correct metadata are all present and the table is loaded, and we just need to run this create table statement. And just like that, once we refresh the ThinkDB catalog, we can see that the new table is now created. And this is in fact an iceberg table, because if we actually navigate over to the Data Explorer, we can see that the time travel capability is already turned on. So if we navigate to the order methods table, you'll notice that not only there are the table schemas and the data samples, there's also a time travel tab telling me the operations that was just performed on this particular table to create the table and loading it with the records. If we actually go back to the SQL editor, we can also query this data as well. So just to close out, we're going to quickly select this table and query it. And we can see the data sets that are present here. Likewise, if we go back to the Netezza environment and run the same metastore sync job one more time and refresh the catalog, We can also see that the table that we just created inside of Lakehouse is now immediately available to Netezza to be picked up and worked on and to query from. And we're going to query over here in Netezza to show that this is in fact the same table that we just queried over inside Watsonx.data. And just like that, we have the exact same table queried from Netezza. You can also perform additional operations inside the lakehouse and transformations, and this is all going to be synchronized between Netezza and Watsonx.data, remove the need to duplicate data or ETL when working across these two environments, saving tons of time. So now that we've seen how users are able to leverage the capabilities provided by Watsonx.data, working in the paradigm that they're used to, looking at technical metadata, notes, comments, and in the SQL editor. How would this look like in the future when we infuse it with automation and AI? That is what we're going to do here with semantic automation. A capability built on top of Watsonx.data with our own foundational models from Watsonx.ai, showing the customers that not only we're looking to infuse our products wherever makes sense with AI, but also leveraging our own technologies within our own products to help data engineers to accelerate on their job, as well as opening the doors for business analysts to better self-service and to do a lot of these data manipulation jobs themselves so that they don't have to have multiple handoffs to get the answers they need. So in this case, we're going to explore how using the chat prompt can help me discover data, and then how semantic enrichment is really going to help customers. So in this case, if I'm wondering about why customers are churning for my product, and I have a hypothesis that maybe this can be explained by economics data or otherwise, I may be interested to start off with customer churn information. So let's click on a prompt and see what happens if I ask the chat to tell me about data that's relevant to customer churn. So just like that, by generating the APIs and the SQLs, it's able to return me a number of tables that's related to the questions that I just asked about customer churn. So let's look into one particular table. Let's start off with the individual customer churn facts. If I select this table and click View, it actually generates a chat prompt to bring up the table details. And what's really interesting is that you'll notice that this table name is actually just a string, not something that is more semantically enriched. And if we actually disable this semantic enrichment aspect, what you'll see is very raw metadata. Strings of column names, types, primaries, and a brief description will be very difficult for someone that doesn't understand this data to look at it and understand exactly what this data is trying to describe and how to best leverage it. If we enable the semantic enrichment over here, we see that with our foundation models and AI, a number of very interesting details are generated. Starting off with the name, turning a string into something that is more readable, the description also clearly showing users what they're actually looking at, primary keys for engineers to understand what can be used to join against other data sets, and also tags that can be used for searches. Also, what's more powerful is that for every single one of these columns, a description is also generated, showing the users what these columns could be indicating and showing. If a customer already has a business glossary, all that work is not going to waste. We can generate a concepts and map to those concept descriptions so that the exact descriptions for those concepts can be pulled in and mapped to this technical metadata. And this is all being done by AI. No human input is necessary. No data model needs to be defined. You can simply load in a file and it will add it to a collection and generate the necessary enrichments and do keyless joins from there. But search is really just one aspect. It only tells it, this is good if I'm looking at one piece of information. But what happens if I want to relate additional pieces of information? What happens if I want to join this information against residency data or geolocation data, for example? Traditionally, I'll have to look through documentations, finding the right tables, and also to ensure that there are actually good containments between these two data sets so that a good join can be done. But here, all I have to do is ask the chat, hey, let's add residence data to this table. With a simple chat prompt like that, this tool is able to look in the collections, identify the relevant tables that can be useful, and also the ones that have good containment. So in this case, if I click on geographic areas, you'll see that this table has a 100% containment, which means that there's at least one column with 100% matching on all the rows. And if we actually want to take a look, we can see exactly how these two tables look in terms of actual data sets. And notice here, it highlights the exact containment columns that I identified, which is the area ID column with 100% matching. And this is also a good time to take a look at these two tables to see if they're actually of interest. Again, let's say that these two tables are of interest and we do want to join. So we're going to join this table. And Watsonx.data's semantic automation capabilities are also able to perform the join, save it, and enrich on the resulting set. So here we're going to name it joined individual custom return facts and add it to one of my collections. And here it's generating the necessary SQL to do the actual joins and then calling the APIs to enrich on the resulting joined table. And just like that, we have the tables that are joined and new descriptions added to show exactly what we've done. So if we actually read the description here, the description now reads that this is the number of customers that churn from one service provider to another, joining with the name of the geographic areas. So really able to be dynamic with the user as they perform their jobs, so that whatever actions that they take, the tool is intelligent enough to keep up with the users and provide them the latest enrichment. And this is also the case if I were to add a new files and trying to join against this table. It doesn't require prior data model definitions and is able to do so on demand as well. So I am going to conclude the demo here and open it up for further questions. Thank you everyone so much for attending today's session.